Okay, let's have a look here at this one now. Again, the proof, de Morgan's theorem, I've done it a couple of times now. It's in the proof by induction section, and there's non-proof by induction. Um, there's proof other. There's not just proof by induction. There's other ways to prove. There's actually three ways I'm aware of now. There's one way that came up recently, kinda, but there's a method used in Taylor series, but that's not on the syllabus anymore. So it's really proof by induction is the only way to prove it. So go to the proof by induction page, and you'll see the proof there. It comes up from time to time. And the question here is a fairly standard find cos 5 theta. So you use de Morgan's theorem. Cos theta plus I sine theta power 5 is equal to cos 5 theta plus I sine 5 theta. That's de Morgan's theorem. And then we can expand. 6, 4, 1. So it's 1, 5, 10, 10, 5, 1. So you'll have cos 5 theta plus 5 cos 4 or cos power 4 theta I sine theta plus 10 cos cubed theta I squared sine squared theta plus 5 cos squared theta I cubed sine cubed theta. So 1, 5. Oh, that's a 10, not a 5. It's 10, 10, 5, 1. So then it's 5 cos theta plus I power 4 sine power 4 theta. I'm going to run out of space. And then plus the last one, which is I5 sine power 5 theta, and that's equal to cos 5 theta plus I sine 5 theta. We only care about the real components. So that's imaginary. Let's forget about that. 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 So we'll have cos 5 theta equals cos power 5 theta, which is fine, minus, because I squared is minus 1, 10 cos cubed theta, which is fine, but then sine squared, which is not fine, but we can change that into 1 minus cos squared theta. And then plus 5. Now, I power 4 is I squared squared, which is 1. So that just becomes, that's a multiplied there, by the way. That just becomes 5 cos theta, which is fine. And then what's not fine is the sine power 4, which is sine squared squared. So squared sine squared, but sine squared is 1 minus cos squared theta. Okay, so this is equal to, now what's quite common, rather than writing cos each time, we'll just write c. So this is c power 5 minus 10 c cubed times 1 minus c squared plus 5c, and then this is 1 minus twice the first by the second plus the second squared. So that will equal cos power 5 minus 10 cos cubed plus 10 cos 5 plus 5 cos minus 10 cos cubed plus 5 cos 5. So how many cos power 5s do I have? I have 1 here, 10 here, and 5 here. So that's 16 cos power 5 theta. And then onto the cubes, I have minus 10 here and minus 10 here. So that's minus 20 cos cubed theta. And then the last one is plus 5 cos theta. Now the way you can check this is, for example, you could choose an angle for theta. Let's say theta is 10 degrees. So cos 50 should be the same thing as cos 16 cos 10 power 5, and so on. So if I just open up the calculator here, just to confirm my answer, if I type in 50 and then, I don't have a science calculator. Let me open the web here. Okay. So if I type in, let's say cos 5, we'll just say theta is 1 radian maybe, or 1 degree. Or no, we'll make it 10 degrees. So cos 50 is 0.64. Okay, so this is just a bit of a rough work check. 0.64. Is that the same thing as, okay, so cos 10 power 5. Let's have a look here. Minus 20. Hang on. Power 5 minus 20. I'll just type the whole thing in. Minus 20 power 3. So this is cos 10. And that's cos 10 power 5. 16, not 16. Cos 10 power 5 minus 20 cos 10 power 3 plus 5 cos 10. And that is equal to 0.64, which is what I just said a moment ago. So in an exam, I'd be quite confident that I got this question fully right. So I've done exactly what they said. I've written cos 5 theta as a polynomial of cos theta. There it is there. That's the polynomial of cos theta then. Okay, and I did a sort of calculator trick here to check that I got the right answer, and it all checks out. So I'm satisfied that this question is finished.